Hello students, today's agenda is to check homework. We'll be graphing absolute value and you will be able to do 5.6. Today students will be able to graph absolute value functions by using a table and analyzing it with its mother graph. So we've seen mother graphs, but it's been a while and I just wanted to do a super quick introduction, just reminding you of what those were. If you have the absolute value, just the absolute value creates this graph, and I'll show you in a minute how or where it comes from. But I wanted to show you that if you have other things going on, like in here you're adding 2, if you're adding 2 or any number outside of the absolute value, what it means is that your graph will go up 2 spaces, and that's for every single point. Every single point goes 2 spaces up. If you're subtracting outside, then your graph will go down, like in here. It says that you have the absolute value minus 6. What does that mean? That you're going to move your graph 6 spaces down. Every single point goes 6 spaces down. Okay. Now, if you're adding or subtracting inside of the absolute value, that means that you're going to be moving your graph, but not down or up. It's going to go to the sides. But most interesting is that if it says plus 3, you're not moving it towards the positives, but rather to the negatives. Plus 3 inside of the absolute value, you move your mother graph 3 spaces to the left. Minus 4 inside of the absolute value is going to move my mother graph 4 spaces to the right. Okay, every single point moves 4 spaces to the right. And having that, if you need, we also have the reflections and also the stretches and compressions. But if you will need to see those, I'm going to link in the description of this video more videos that describe those other transformations. Otherwise, we're just gonna see them through the lesson a little bit too. Okay, so I'm going to create 2 different tables so that you have an understanding of where they come from. Okay, let me do one more. I'll do 5, and I'm going to put 0 in the middle, and then 1, 2, and -1, -2. This is going to be the values for x. These will be the values for y. And for the mother graph, it just means what is the value of y when you compare it to the absolute value of x. So y is equals to the absolute value of 2. Oh, and also in 5.3, we learned that the absolute value is always positive inside. Whatever is inside becomes positive. Okay, it's just the distance between that number and 0. And so what is the absolute value of 2? Is 2. So y is equals to 2. When x is 2, y is 2. Then let's do the absolute value of x when x is 1. What is the absolute value of 1? 1. So that's also 1. What about the absolute value of 0? Well, y is equals to the absolute value of 0 is 0. Okay. And what about the absolute value of -1? Well, remember that the absolute value just means the distance between 0 and -1, and it's only 1 space. It's always positive for that reason, because distance will always be positive. You're gonna say, oh, my table measures -6 feet. It's always positive 6 because it's distance, is the measurement. Okay, so the absolute value of -1, positive 1. What about y is equals to the absolute value of -2? The absolute value of -2 is 2. So that's where you got the mother graph, and you have 0, 0, and you can start at 2, 2 also. So 2 on x, 2 on y is right there. 1, 1, 1 on x, 1 on y. 0, 0, it's this one right here. -1 on x, positive 1 on y. Remember that this is x and this is y. Negative 2, positive 2, negative 2, positive 2, right there. And it will continue. You can think that it's going to be 3, 3, 4, 4, 5, 5. Same on the other side, but we'll do just those. Okay, so that's my mother graph, but that's not what this function is. It says y is equals to the absolute value of x minus 6. Well, you already saw in the express explanation with the mother graph that it's just going to go down, but these are the reasons why. Okay, so 0, 1, 2, and on this side, negative 1, negative 2. I'm just writing the same ones. So we're going to do the same thing as we did with the mother graph. I'm going to substitute x with these values of x. And so the absolute value of 2 minus 6, the absolute value of 2 is 2 minus 6, and that's 2 minus 6 is negative 4. For the next one, we have y is equal to the absolute value of 1 minus 6. The absolute value of 1 is 1 minus 6. 1 minus 6 is negative 5. So that's my next value for y. For the 0, y is equal to the absolute value of 0 minus 6. The absolute value of 0 is 0 minus 6 gives me negative 6. 0 minus 6 is negative 6. And then y is equals to the absolute value of negative 1 minus 6. Absolute value of negative 1 minus 6. And the absolute value of negative 1 is positive 1 minus 6. 1 minus 6 is negative 5. And finally, y is equals to the absolute value of negative 2 minus 6. The absolute value of negative 2 is positive 2 minus 6. 2 minus 6 is negative 4. Remember that when we have a positive and this becomes a negative, so it's positive and negative, we subtract. 6 minus 2 is 4, and leave the sign of the greater one. In this case, it's the negative 6, so negative. Now that we have the table for this new function, you just start graphing 2, negative 4, 2, negative 4, it's right there. 1, negative 5, 1, negative 5, it's right there. 0, negative 6, 0, negative 6 is right there. Negative 1, negative 5, negative 1, negative 5 is right there. Negative 2, negative 4, it's right there. And you can see that every single point went 6 spaces down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And you can count the other ones and you will see that every single point goes down 6 spaces. So that's my mother graph, and that's the transformed function. Okay, for number 2, we have this function. We know already that our mother graph for absolute value will be exactly like this. Same on the other side. Okay, and you can only do 3 if you want to, 3 points on each side, and that's fine. Yikes, I smeared it. And so now let's do the table. Y is equals to the absolute value of x plus 2. So y is equals to the absolute value of 2 plus 2. The absolute value of 2 is 2 plus 2 will be 4. Y is equals to the absolute value of 1 plus 2. So all I'm doing is just substituting these values of x on the x for my function that I was given. And so in here, the absolute value of 1 is 1 plus 2 gives me 3. again, the absolute value of 0 plus 2. The absolute value of 0 is 0 plus 2. Anything added to 0 will always be the other number. Okay, when it's multiplied it's 0, but when it's added it's the other number. So 2. Then for -1, y is equals to the absolute value of -1 plus 2. The absolute value of -1 is +1 plus 2 gives me 3. And the last one, y is equals to the absolute value of -2 plus 2. The absolute value of -2 is +2 plus 2 gives me 4. And so now that we have our table, we can start graphing. And it's easier to see when you start with 0. 0, +2 goes right there. And then you can do one side and then the other side. So +1, +3, +1, +3 is right there. +2, +4, +2, +4 is right there. Now the other side, -1, +3, -1, +3 is right there. -2, +4, -2, +4 is right there. And you can see that every single point went up 2 spaces. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2 will be right here. So again, if we know that the absolute value for our mother graph is this, and that we're just adding 2, you can just move the mother graph up 2 spaces. This has 2 transformations. From my mother graph, which is right here, it says that inside you're subtracting 4, so you're going to be moving the graph to the right 4 spaces. But then we have this negative outside. That is a mirror. Again, if you need more description related to that, they're going to be in the description of this video. But okay, so you can do this transformation first or this one first. To me, it's easier to do the transformation of the mirror, because all you're doing is a mirror outside is a reflection on X. It's like you're going to outdoors and you don't have a mirror. Where do you see yourself? In the little river or in the water, the lake. And that your reflection, if this is you, your reflection will be down here. So that will be easier. You just reflect all the points on X. Okay, so if that was the only transformation, your graph will be there and that will be done. However, it says move 4 spaces to the right. So this mirror graph will be moved 4 spaces to the right. So right here, and then you'll see that it's going like that, right there, right there, right there, and just go like that. And now this is for reals the graph with the 2 transformations, and then this is every one diagonally, so somewhere like that. So that's just using the mother graph with the transformations. Now let's try with the table, and let's do that again. Okay, so again, all we're doing is substituting the values of X and then figuring out what Y will be. So for the first one, X is 2. So the negative of the absolute value of X, which is 2 minus 4, inside of that absolute value. I'm going to simplify that first. The negative just keeps coming down. And 2 minus 4 is -2 inside of the absolute value. Bring down, don't multiply negative times negative. No, first you have to simplify the absolute value. This, you just bring it down, and so the absolute value of -2 is +2. But that negative was from here, okay? So the answer is -2 in here. For the next one, y is equals to negative absolute value of 1 minus 4. And so bring down the negative. 1 minus 4 is negative 3. And bring down the negative. The absolute value is positive 3. So it becomes negative 3. The negative is from the sign that it's outside. Okay. Again, never multiply a sign outside of the absolute value with a sign inside of the absolute value. For 0, y is equals to the negative of the absolute value of 0 minus 4. Bring down the negative. The absolute value of 0 minus 4 is negative 4. Bring down the negative. The absolute value of negative 4 is positive 4. And because of the negative outside, that's negative 4. Y is equals to negative. Absolute value of negative 1 minus 4. Bring down the negative outside. Work whatever is inside of the absolute value. Negative 1 minus 4 is negative 5. Bring down the negative. What is the absolute value of negative 5? It is positive 5. But because of the negative outside, it's negative 5 for the answer. Finally, y is equals to negative of the absolute value of negative 2 minus 4. Okay, negative 2 minus 4. And so, bring down the negative. Negative 2 minus 4 is negative 6. And so negative from the sign outside, the absolute value of negative 6 is positive 6. So the answer is negative 6. So let's check these points that we have, and so that we can see where our graph is. So 2, negative 2. 2, negative 2 is this one right here. We're just checking some of the points. 1, negative 3. 1, negative 3 is right there. 0, negative 4. 0, negative 4. And you know what? I just realized that I should have chosen some of these numbers. Let me check just so you can see. Okay, let's do 4, 5, and 6. So maybe I'll put them up here. Maybe even 3, 4, and 5 instead. Maybe knowing that this with our mother graph is going to move, this is going to move to 4, maybe it will be a good idea to just use 4 and the 2 to the left and 2 to the right. So 2, 3, 4, 5, 6 would have been better in this case, but that's okay. Y is equals to, let me do the 3, negative of the absolute value of 3 minus 4. Negative of 3 minus 4 is negative 1, which is equals to negative. The absolute value of negative 1 is positive 1, so that's negative 1. And you can see 3, negative 1 is right there. 3, negative 1 is this one right here. For the 4, y is equals to negative. Absolute value of 4 minus 4. Which is negative. 4 minus 4 is 0. And negative absolute value of 0 is 0. But remember that 0 is neither positive or negative. It's just neutral. So 4, 0 is right there. 4, 0 is this point. And let's do just this one more. Y is equals to the negative of 5 minus 4. Bring down the negative. 5 minus 4 is 1. And the absolute value of 1 is 1. But bringing this negative from outside is negative 1. And you can see 5, negative 1, 5, negative 1 is right there. Okay, so that's creating a table. Again, I guess you have to analyze and see which points will be more appropriate by looking at the one on the origin. Let me choose that with number 4. So you can see. Okay, ready? So now, by knowing that my mother graph will be here, and looking at the function that it has plus 3, it means that it's going to go to the -3. So guess what? I recommend that you put -3 right here for the value of x. And then if this is if this will be going here, then maybe choose 2 from each side. So -4, -5, and the other ones on this side. So that's -4, -5. On this side, -2, -1. Y equals the absolute value of -1 plus 3. Absolute value of -1 plus 3 is +2, which is equals to 2 because it becomes positive. These are magic sticks. Y is equals to the absolute value of -2 plus 3. -2 plus 3 is 1, which is the absolute value of +1 is +1. Then the absolute value of -3 plus 3, all I'm doing is substituting the x. The absolute value of 0, which is 0. Then -4. The absolute value of -4 plus 3. That's -4 plus 3 is -1. And the absolute value of -1 is +1. The last one, the absolute value of -5 plus 3. -5 plus 3 is -2, but inside of the absolute value, that makes it +2. Now we have our table done. Now think about it. In here, again, each point should go 3 spaces to the left. If it's positive, you're adding inside, it goes on X, opposite of the sign, okay? Let's see. -1, +2, -1, +2 is right there. -2, +1, -2 on X, +1 on Y. -3, 0. -3, 0 is right there. -4, 1. -4, +1 is right there. -5, 2. -5, +2 is right there. And so that's my new graph. Okay, for number 5, I already did the mother graph and the table. I prepared it. And why did I choose 0, 1, 2, -1, -2? It's because it's just multiplication and a reflection. When we have a negative outside, that's one transformation on itself. That's going to be a mirror on X. And the 3 outside is a vertical stretch. In this case, what you're doing is getting the absolute value of the X. I'm just doing it with them as a mother graph, okay? The mother graph and then the transformations. The mirror, it just tells me, put all the points in the reflection. If it's outside, the reflection is on the river, okay, or the lake. So 2 up, then it reflects 2 down. 3 up, it reflects 3 down. Same on the other side. 1, then it reflects down here. 2, it reflects down here. 3 reflects down here. So that's my reflection. I just have done the negative if you're just doing transformation with the mother graph. Times 3, it just means you need to multiply that by 3. So in this case, if there is 1 space away from the x-axis, then times 3 is 3 spaces. So again, come from the x-axis, 1, 2, 3, right there. So this is now the real one. And here is 2 spaces times 3 is 6. So count again from here. 1, 2, 3, 4, 5, 6. And then this one is going to be 9. So because 3 times 3 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, more or less. Okay. Same on this side. Instead of 1 is going to be 3. Instead of 2, 2 times 3 is 6. Instead of 3 is going to be 9, more or less right there. And so my real new graph is going to be like this. So what are the two transformations that we did? We mirrored it on X and then stretched it vertically. Okay, multiplying it by 3. Now let's use our table to double check our answers and also to find a way to graph those. So if we have y is equals to -3 times the absolute value of x, all you're doing again is replacing the value of x, so -3 times whatever is in there, but taking the absolute value of that, bring down the -3, the absolute value of 2 is 2, so that's times, it's multiplication, okay? And -3 times 2 is -6. Now for the 1, y is equals to -3 times the absolute value of 1. -3, you just bring it down. The absolute value of 1 is 1, so you're going to multiply that, and -3 times 1 is -3. For the next one, y is equals to -3 times the absolute value of 0. -3 times, what is the absolute value of 0? 0. -3 times 0 is 0, so right there. Y is equals to -3, times the absolute value of -1, because that's the value of x. And so -3, what is the absolute value of -1? +1. And -3 times +1 is -3. Finally, -3 times the absolute value of -2. -3 times, what is the absolute value of -2? +2. And so -3 times 2 is -6. And now let's just check these points. 2, -6, 2, -6, right there. 1, -3, 1, -3, right there. 0, 0, right there. -1, -3, -1, -3 is that point right there. -2, -6, -2, -6 is right there. So basically, we graphed only these 2 points, but still the graph is there because it will continue on and on. Or if you want, you can just add a 3 here and a -3 here if you want to check the other 2 points. You know how in number 3 I didn't choose the right points, and that's why we had to add some more up there. So how do we choose those points? The ones that are going to help me will be the plus and minuses. Those are going to guide me to choose the right point right here. And so what you're going to do is that we'll go to the left because it's positive. So that means it's going to be -2. That's the point that you want to put in here. Okay, -2. And then from there, just go -2, -3, -4. And then up will be, after the -2 is -1 and 0. Okay, so just go, see, it's the opposite of whatever is inside basically. Okay, and then from there, 2 points on the left, 2 points on the right. So for my mother graph, this is what it would look. This tells me that it's going to go 2 spaces to the left and 3 spaces up. So 1, 2, 1, 2, 3, right there. This will go right here. And that will be right here. Right, where you just go like this, but that's not the real one. Hold on, because there are 2 other transformations. It's a stretch and it's a mirror outside, a mirror on the river. So that means that this will mirror right here. So basically it's just saying, oh, it goes that, like that. Because of this minus, it'll mirror down. But then it says multiply by 2. So it's not going to be in here, but rather times 2 is right here. And the other one, this point, times 2 is 4. This 3 times 2, hold on, I'm getting lost here. 3 times 2 is 6, so 3, 6. And I know I'm not giving a lot of detail, but you can go check those videos or just do your table, okay? So this is where my graph where it will end up once we do the table. Okay, that's where it should land. Okay, so let's start working on it. Y is equals to -2 times the absolute value of x, which in this case is 0 plus 2, and then add 3 after that. So -2 times 0 plus 2 is 2 plus 3. -2, you just bring it down. This is what you need to do first. Take the square root, not the square root, take the absolute value of 2, which is +2, and then add 3. -2 times +2 is -4, plus 3 gives me -1. So that's the first value. For the second one, for -1, you do the same thing, just substitute this and then start simplifying. Remember that you have to simplify whatever is inside of the absolute value first. So -2, the x is a -1, plus 2, plus 3. Bring down the -2. -1 plus 2 is +1, plus 3. Bring down the -2. The absolute value of 1 is 1 plus 3. -2 times 1 is -2 plus 3. And we subtract and leave the greater sign. Whenever the signs are different, we subtract. And so the answer is 1. Okay, I'll do it here. Y is equals to -2 times the absolute value of -2 plus 2 plus 3. -2, and here we'll get 0 because -2 and +2 cancel, plus 3. -2 times 0, the absolute value of 0 is 0, plus 3. -2 times 0 is 0, plus 3 gives us 0 plus 3 is 3. So y is equals to -2 times -3 plus 2, and then add 3. Bring down the -2. -3 plus 2 is -1 plus 3. Bring down the -2. What is the absolute value of -1? +1 plus 3. -2 times 1 is -2 plus 3. And if I owe 2, but then I pay 3, I still have 1. The other one, y is equals to -2 times -4 plus 2 plus 3. All I'm doing is substituting x with a -4. -2 times -4 plus 2 is -2. Add 3. Bring down the -2. What is the absolute value of -2? It's +2. Remember that you're multiplying in here. When there is nothing, it's multiplication after you simplify the absolute value. Bring down the plus 3. -2 times 2 is -4 plus 3. And -4 plus 3 is -1. Now let's check to make sure that our table meets with our transform matter graph. Okay, so 0, -1, 0, -1 is that point right there. -1, +1, -1, +1 is that one right there. -2, 3, -2, +3 is right there. -3, +1, -3, +1 is right there. And -4, -1, -4, -1 is right there. Again, if you want to check more points, you can add the -5 and also the 1 to find those 2 points. I apologize for such long video, but we are kind of like doing a new topic by reviewing it with another one and just making sure that they match. Again, if you want to see more on transformations, you can see or check out the description of this video, and you'll find more videos related to mother graphs and their different transformations. Also, please give us a thumbs up, subscribe around here. This is the link to the entire unit, and here you will find the next lesson. Now you're able to do 5.6 and have fun.